And this is lesson 5. We're going to talk about measuring variability for symmetrical distributions, which is a lot of words for, we're going to take a look at standard deviation. Today, that's what we're working on, standard deviation, which means we will need the mean, and then we're going to find out how far away something is from the mean. This first example is an example worked out for you. And what we're going to do is I'm taking my highlighter and I'm going to switch over to my pen too, and I'm going to annotate it. So here's a dot plot of the lives of brand A batteries from lesson 4. Okay, we saw this. We just saw this in the last video. It's in hours, so these batteries are between 94 and 115 hours of battery. So how do you measure the variability of this data set? Okay, variability. Changes. Amount of change. Amount of change. It varies, right? So it changes. So how do we measure the amount of change of this data set? Okay. We're going to use standard deviation. Amount of change. Also known as variability. Okay, first find each deviation of the mean. Okay, the mean we're going to find. It's x hat. X hat. So, didn't we already find the mean for this guy? The mean, was this from battery A? Oh yeah, from the last video, was 101. This added up to be, if we added all these together, it was 606, and then you divide it by 6, and then you get 101. X bar, that's the mean. That's how you say it. X bar, like B-A-R, like a chocolate bar. Okay, then square the deviations from the mean. For example, when the deviation is negative 18, the square deviation of the mean is 324. Okay, so I have to do this. Oh, all these are positive. All positive values. I'm squaring it, right? Everything that's square should be positive. Okay, then my next step, first step, second step, add up the square deviations. The row is the sum, adding. Then divide by, wow, there's a lot of things, n minus 1. This discussion, why it's n minus 1, I don't know if I can have it in this video. I think it's something that we can have in class. But basically, when you have a large set of data, you don't have to subtract 1 because it just is so negligible. Like if you did the population of the US, there's like hundreds of millions of people here. So you wouldn't have to do the minus 1. But since we're working with a data set of 6 points, if you do minus 1, the variability actually works out better. This is why stats is weird and wonderful at the same time. Mostly wonderful though. Okay, what are we dividing by? We are dividing the sum. Oh, okay, this sum is up here now. We're dividing by n minus 1. I know n is 6. 6 minus 1 is 5. Okay, 147.2. What is this? This is the deviation squared. So in this case, the units in our problem is hours squared. But we want the deviation to be just hours. So we're going to have to square root this, which means we're going to have to square root this guy. And we're rounding it to the nearest hundredth. Keep your decimals to, if you have a square root and there's 1 decimal, your answer should have 2 decimal places. Okay? And apparently we calculated the standard deviation. We calculated the standard deviation. It seems like a very complicated process at first, but you will soon get used to it. We conclude that the typical deviation in brand A is 12.13 hours. Is that what we got? Yes. The unit standard deviation is always the same. Okay. How close is the answer to the typical deviation that you estimate at the beginning of the lesson? I think we estimate like 10 at the beginning of the lesson, like, which means they vary by 10, like 83, 94, that's about 10. This is about 10. And then from here to here is about 10. The difference, how different they are. Now we actually know that the deviation from the mean is 12.13 hours. Let's practice calculating it, but with brand B. Or, yeah, brand B. Exercise 1 this is still from lesson 5. Now you can calculate the standard deviation from the 8 brand B batteries. The mean was 100.5. Looks like a temperature. We already have the deviations from the mean. Oh, they're so nice. So I'm looking, here's negative, and then here positive values. This squared deviation must always be positive. Always positive. Which makes sense because we're about to square each of these numbers to get positive values. All right, so let's do 27.5 squared. 75625. 75625. Yep. Now let's do 24.5. 24.5 squared. 625. If you can't read this on the screen, go punch it in your calculator yourself. I don't want to be mean, but I'm going to be mean. Okay, 8.5 squared. 8.5 squared. 72.25. Oh man, even I'm having trouble reading this. Okay, I did this ahead of time, so I'm going to make this go faster. This is, I'm going to zoom in. 42.25. 9.5 squared is 90.25. 16.5 squared is 272.25. 17.5 squared is 306.25. And then 23.5 squared is 552.25. Okay, so we squared all the standard deviations. And we do this because now when we add up our standard deviations, it won't equal 0. If you recall, if we add up all of our deviations, that's going to equal 0. That's not very helpful information for us, except the fact that the mean did a really good job about being in the middle. Now we're going to find the deviation of the mean. So write the square deviations in the table, check. Find the mean, check. Calculate the deviations, check. Square the deviations, check. Add up all the square deviations. Now let's add these all up. Okay. So, we're going to do 756.25 plus 600.25 plus 72.25 plus 42.25 plus 90.25 plus 272.25 plus 306.25 plus 552.25. Enter. 2692. Okay. Square deviation 2692. What is the n for this data? N is the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. Divide the sum by n minus 1. N minus 1 equals 7. So we're going to do 2692 divided by 7. And we get 384.57. And we're going to take the square root. Okay, add up the square deviations, divide by n minus 1, take the square root. Okay, let's take the square root. Where am I? 19.61. Okay. Oh, round to the nearest hundredth. I did. Wait, I should actually check. 610. Okay.